While the world is frantically searching for the fuel of the future, a plant had already done it more than a century ago. No laboratory required, no complex technology needed, just plant it in the ground, wait for it to grow, and harvest it. This plant can replace gasoline. It can run diesel engines and provide energy for almost every familiar machine. But there is something very strange. It has almost disappeared from modern life, no longer appearing in books, no longer being mentioned, as if it never existed. Not because it was ineffective, but because it worked too well, good enough to force an entire system to change, powerful enough to become a threat. My name is William. I am 70 years old this year. I have spent most of my life studying ancient plants, things that once sustained humans through many generations. If you care about clean food, about forgotten knowledge, and things that are no longer taught, subscribe to the channel, turn on notifications, and leave a positive comment below, because in this video, a truth will be revealed. A truth that has been buried for nearly a century, related to a plant and a system few have ever questioned. But before knowing what it is, you need to understand something more important. Why something so powerful was erased from the world. That plant is called hemp, also known as cannabis sativa. This is not a new concept, but a biological energy system that has existed for a very long time. The hemp plant has a unique structure. Every part of it can be converted into fuel. No part is wasted during the process. The seeds of the hemp plant contain a high amount of natural oil. This oil can be extracted using a simple and stable cold press method. Oil from hemp seeds can be converted into biodiesel through a basic chemical reaction. This process does not require complex technology. Biodiesel from hemp is compatible with most existing diesel engines. No need to change the engine structure. No need to adjust the operating system. The stalk of the hemp plant contains cellulose. This component can be broken down into simple sugars through standard biological processes. The simple sugars are then fermented to produce ethanol. This is a type of fuel already present in today's gasoline system. Ethanol from hemp can be directly blended with gasoline at common ratios. The usage process does not change the engine's operating mechanism. The entire hemp plant functions as a closed system, a single biological source, two separate types of fuel, two different engine systems. This is not a theory. This is a complete solution. And it once existed before being removed from the modern system. Hemp does not only produce fuel, it also directly aligns with the original design principles of the diesel engine in the history of technology development. The diesel engine was built based on compressing air to generate high temperature. Fuel is injected and self-ignites without the need for a spark. This mechanism allows the use of many types of fuels with different viscosities and combustion properties, including oils derived from plants. Oil from hemp seeds has combustion characteristics suitable for high-pressure environments, helping the engine operate stably without changing the original design. This capability is not a new improvement. It is part of the original design. The diesel engine was not created solely to serve petroleum. In the early stages, biofuel was considered the main direction of development because it could be produced directly from agriculture without deep industrialization. Hemp plays the role of a local energy source, allowing production, processing, and usage within the same closed system. This eliminates dependence on transportation, eliminates the need for large-scale storage, and reduces reliance on complex supply chains. This system creates energy independence at the individual level, at the small community level, and in environments without large infrastructure. This independence goes against the centralized energy model, where production and distribution are controlled by a small number of large organizations. When fuel is produced locally, control over energy no longer belongs to a central system, but shifts to each user unit. In this case, hemp is not just a raw material, but part of a complete decentralized energy model. However, this model was not maintained in the modern system. The direction of development shifted toward fossil fuels on a large industrial scale. This transition did not come from technical limitations of biofuels, but from changes in the structure of energy control. As a result, during an originally flexible design, capable of operating with biological sources, became tied to a single type of fuel. And from there, the entire operating system became dependent on petroleum, a source of energy that requires extraction, refining, and long-chain distribution. Hemp and biofuels did not disappear because of technical limitations. The change happened when the energy system began shifting toward petroleum. Petroleum can be extracted centrally, refined at large scale, and distributed through a tightly controlled system. This created a new energy model, where supply no longer exists locally, but depends on large-scale industrial production chains. As this system expanded, biofuel from hemp gradually lost its place in the energy structure, not because it was less effective, but because it did not fit the centralized model, a system that requires control from extraction to distribution and consumption. Fuel from hemp can be produced locally. No need for long-distance transport. No need for complex storage systems. This reduces dependence on major energy supply centers, at the same time weakening the role of distribution systems. When control over energy becomes decentralized, centralized management becomes difficult to maintain. This is the factor that changes the entire system structure. From there, a transition process took place. Biofuels were gradually removed from industrial and commercial standards. Technical systems were adjusted to match fossil fuels, creating long-term dependence on a single energy source. Hemp no longer appeared in the main supply chain, no longer integrated into large-scale energy production systems. This disappearance did not happen instantly, but step by step, through changes in standards and development direction. The result was a new energy system, based on the extraction of finite resources. Instead of renewable biological sources, in that system, fuel from hemp was no longer prioritized. Even though the technical capability still existed and was never lost, this shift created a large gap between what is technically possible and what is maintained in reality. From there, a complete energy solution gradually disappeared from common awareness and no longer exists in the modern system. The hemp plant is not only compatible with diesel engines, it is also directly connected to the early development direction of fuel for gasoline engines. The gasoline engine system is not limited to a single type of fuel. Many types of fuel can be used as long as they meet combustion requirements. Ethanol is one of the important options. This is a type of fuel that can be produced from plant biomass through the fermentation process. The stalk of the hemp plant contains cellulose. This component can be converted into simple sugars and then fermented to produce ethanol. Ethanol from hemp has combustion characteristics suitable for gasoline engines. It can be used independently or blended with gasoline at standard ratios. This capability allows the hemp plant to become a fuel source for both engine systems, diesel and gasoline. Within the same production cycle, this creates a dual energy model, a single plant, two different types of fuel, two parallel operating systems. This model does not require the extraction of finite resources, does not depend on petroleum, and can be renewed through natural cycles. In the early stages of development, biofuel from plants was considered a viable direction for transportation and industrial systems. The ability to produce locally helps reduce transportation costs, at the same time increases the stability of energy supply in local areas. The hemp plant in this system plays a central role, not just as a raw material, but as a foundation for a sustainable energy model. However, this model was not maintained in the modern system. Fossil fuels gradually replaced it entirely in both types of engines. This replacement created dependence on petroleum extraction and eliminated the ability for energy independence from biological sources. As a result, a system that once had the ability to operate independently was transformed into a system dependent on global supply chains. The hemp plant still retains its technical properties, but its role in the energy system has been removed from modern reality. The biggest change did not come from technology. It came from a systemic decision, a shift capable of reshaping the entire energy industry. In the early 20th century, a series of policies began to appear. These policies did not directly target fuel, but deeply affected the hemp plant. The hemp plant was placed in the same category as controlled substances. Even though its biological characteristics and uses are completely different, this created intentional confusion. When a material is legally restricted, the entire related production chain is disrupted, from cultivation to processing to real-world application. As a result, the hemp plant gradually disappeared from large-scale agriculture, no longer widely cultivated, no longer integrated into industrial systems. At the same time, petroleum-based fuels were standardized. Technical standards began to revolve around a single type of fuel. Engine systems, supply stations, and the entire energy infrastructure were built to serve petroleum, leaving no room for alternatives. Once infrastructure is established, change becomes extremely difficult. All later improvements must fit the existing system. This creates a lock-in effect. When one option is maintained long enough, it becomes the standard, and other options gradually disappear from reality. In this case, the hemp plant did not lose its technical capability, but lost its position in the legal and industrial system. This removal did not require a complete ban, only prolonged restriction, and the creation of barriers large enough to prevent competition. When supply is disrupted, the related knowledge also gradually disappears, no longer passed down, no longer present in formal education. A new generation grows up without knowing this solution ever existed. This further reinforces dependence on the current system. Meanwhile, petroleum continued to develop, infrastructure expanded, supply chains became more complete and overwhelmingly dominant. The result was the formation of a global energy system based on centralized extraction, large-scale distribution, and continuous consumption. In that system, the hemp plant no longer had a role, no longer considered part of the energy solution. This disappearance did not come from a single factor, but from multiple simultaneous changes, legal, economic, and systemic. From there, a source of energy that once had the potential to replace gasoline was gradually removed from reality and no longer exists in common awareness. The hemp plant did not disappear technically. It was only removed from the official system for a long period of time. Its biological properties remained unchanged. The ability to produce fuel from hemp has not changed. The conversion process still exists. Efficiency has not declined over time. Throughout the period of being excluded from the industrial system, the hemp plant still existed on a small scale. Outside the main production system, this helped preserve part of the knowledge, but not enough to develop into a large-scale energy system like before. The decades-long interruption created a major gap in awareness. When a solution is not used, it is gradually forgotten. Educational and research systems no longer focused on biofuel from hemp. The focus shifted entirely to fossil fuels. This slowed down the development of related technology, not because of technical limitations, but due to lack of investment and priority. However, the core properties of the hemp plant have not changed. The ability to produce biodiesel and ethanol still exists as originally. As legal barriers gradually loosen, the hemp plant has begun to reappear in certain sectors and regions. This return is not a new invention, but the restoration of a system that once existed in the past. Modern research confirms the efficiency of fuel conversion from hemp, especially the ability to convert seed oil into biodiesel. The results show high conversion rates, meeting modern technical standards, and suitable for real-world operating conditions. The process of producing ethanol from the stalk is also confirmed to be feasible, not requiring technology beyond current capabilities. This shows a clear reality. This solution never disappeared scientifically. It was only removed from the application system. When conditions change, this capability can be reused. No need to reinvent, only to reapply existing knowledge. The hemp plant in the current context is no longer a new idea, but a proven solution that has not been fully utilized. The coexistence of technical capability and absence in the system raises an important issue about how energy is chosen. A solution can exist, can function, but still not be deployed on a large scale if it does not fit the system structure. This creates a clear gap between practical potential and real-world application, a gap that has existed for many decades. And this gap is exactly why the hemp plant needs to be rediscovered. Not as a new idea, but as a forgotten solution. The hemp plant is not the only case of biofuel. Many countries have used ethanol in their energy systems for decades. Ethanol is used as a component in gasoline. The blending ratio can vary, but the operating principle does not change. This shows that gasoline engines are not limited to fossil fuels. The system was designed to accept multiple types of fuel. Meanwhile, the hemp plant can provide ethanol from a renewable biological source, without the need to extract finite resources from underground. The difference lies in the supply source. One side depends on extraction and refining. The other can be produced through natural cycles. This capability creates a clear alternative. But that option has not been widely implemented in the modern system. This leads to a reality, not because there is a lack of solutions, but because the solution is not prioritized in the current energy structure. The hemp plant in this case is not an exception, but part of a larger system that once existed. And when placed in that context, The question is no longer whether it works, but why it is not being used. The hemp plant was once considered a potential energy source, but over time, it was removed from the system and gradually disappeared from common awareness. This disappearance did not come from technical limitations, but from how the system chooses and maintains energy sources in reality. When a system is built long enough, it becomes the standard. And other options, even if viable, are no longer considered. This creates a clear reality. Not every effective solution is used. Not every option has the opportunity to exist. The hemp plant in this case represents another possibility, another direction, but one that does not fit the established structure. And when a solution does not fit the system, it can be removed. Even if it still works and still has value, this raises an important question about how energy is chosen and about what is truly maintained in reality. If you have any questions related to this topic, leave a comment below and don't forget to subscribe to follow upcoming content. This video uses AI-assisted tools to help present visual information more clearly and understandably for viewers.